So right now, point's right here. Okay, here's our point gap there. Looks pretty high. It's supposed to only be 16 to 18 thou max. Looks like it's more than that to me. Small little stuff like this. So, I think that's 16 right there. Yeah, small. Okay, we'll check that later. Okay, so see, I slid that over there. Pretty close. Okay, this is our fully advanced point here. Okay, so one way of checking these without having an ohmmeter or light on here, you put a little piece of thin plastic in there, a little cellophane or something real thin. I don't have any cellophane laying around. We have a little thin piece of plastic, but this is not super thin. It's actually pretty thick. But it's better than nothing. I'm trying to think what I have here is thin. So this is about all I got. So this is going to give us a built-in amount of a, let's see, it should advance us a little bit, I would think. I'm alright with being a little bit advanced. Okay, a little piece of plastic. Oh, that's pretty thin. 1 thou thick. That's pretty thin. Okay, we come over here and put this in our points. And when we can move this, we know we have a gap. Then it won't go down in there. There we go. Okay, so I stuck that in our point gap. So it's right here. So once that moves, we know we're good. Okay, so right now we're fully advanced against our stop. So this is how much retard advance we got, which is plenty. It's way more than you really need. About that much is all you really need. So if I move this in to limit the amount of travel we have. Still quite a bit in there. Lock it down right there. Okay, so I'm going to have this much movement here, which is plenty. You can see why this here was cut away on the backside to make room. Okay, we are not hitting on the cover, we are bottoming out on a screw inside here, so that's our full retard. Full advance is over here. Okay, now you just rotate this magneto until this here gets loose, and it would be timed. If you had an LED light up on there, the light would light up. If you had a buzz box, it would buzz. If you had an ohmmeter on there, the ohmmeter would move. Lots of different ways of doing it. This is the mechanical way of doing it. So I just rotate this until this gets loose. It's loose. Came out. Okay, so this should have a lot more advanced timing than stock at this point. So we're going to lock this thing down right here. Still works. Pretty tight. Pretty tight. Okay, we still move this way, so we're good. Okay, now we want to double check this. Make sure we're moving the cam all the way backwards, as far as we can anyway. Okay, what do I do with my little feeler gauge piece? I lost it. What do I do with it? I laid it right in front of me here. Might have blew away. Yep. Not blowing. Here's my tool. Went bye-bye. See, that's the problem. You make your tools too invisible. I don't know where they went to. Alright. Looks like we lost our tool. Geez, I wonder if I can possibly find another one. Okay, laid it right there. Suppose it went to the ground somewhere, did you? I don't see it. Well, we'll just make a new one. That's why we got a whole bunch of plastic here. Yeah, there you go. Yeah, I found a new one. Maybe we should mark it so we know where it's at. If you mark it, you might get the points. We don't want to do that. Okay, so now I'm going to try to put this thing inside the points right here again. Where's my little screwdriver at? We're going to open the point up pretty far this time. Nope, didn't work. It's got a curve in it, and the curve is fighting me. There we go. Pre-bend it. Boom. Okay, right now we are hooked because we're retarded all the way. See, it moves back and forth this far. Okay, so we're going to retard it. Make sure the cam's all the way back. Put a little pressure on that. Right there, it starts sliding up. Just a little bit more to go. That's about a quarter of a turn on the screw over there to adjust it to make it what we want. Okay, so that has a little bit more advanced than what that is. Should I lose this again? I put it right back in the same spot. Okay, so basically we go back about that far. that's about how much extra we had when I first started to be able to move it just a little bit there. So that's like 2 thou a point gap is where we're at right now. Now we should be set on center flower right now. My timing mark. Yep, it hasn't really moved. It's slightly to the back, which is fine, advanced. So it's probably about maybe half of that distance again to the back. So it's 4 degrees from the center of the window to the edge of the thread. It's 5 behind the thread. So we might have an extra 3 degrees to 4 degrees extra timing in the motor, which makes them run better. It's about 48, 49 degrees of lead. Makes these things run really nice. Okay, so if you want to take that out, all we got to do is loosen up this nut, give it about a quarter of a turn on the screw, and that'll pull it back just a little bit to where it's neutral timing point. So if he takes this and marks the screw with a felt tip like this, right here, so right now it's set in this position here. If we rotate that from there to about here, it'd probably be almost straight up and down. If we went about a quarter of a turn down this way, it should be right on the money on the timing mark over there. Now all of that will fluctuate depending on all the backlash and everything in the cams. We don't know where they're at. That's why these things vary. And after you break the motor, you should come back and check this again. Now right now we had this marked down here. So my initial mark was way over here, and see now we're way over here. So what we got to do is try to wipe that clean so that disappears. There we go. Wipe most of that off. Now usually what I do is I take my felt tip marker and I'll just put a mark across where it's going to matter. So if you move it, it's going to be between this plate and here, not the handle. So if you take this and mark it straight down like this, like that, you will know if it's ever been moved. Now, after the bike is broken and running correctly, and it's all been readjusted to correct timing, you can actually come by here and hit it with two little prick punch marks, or you put a little slot right there with a little chisel, or you just felt tip mark it. I like just marking with felt tip because those other ones are permanent. This wipes off, you start over again. You got the screw marked over here so you know where you're at. So if you want to put this thing where it's exactly theoretically on center right now, you can loosen up the screw head right here. Where'd my little wrench go? And I had it here. Here it is. 1132 wrench. And that's not a Phillips screwdriver. Take your Phillips screwdriver, unlock it, move it just a little bit. See how much that moves? So maybe about right. It could barely even move it to make that work. That should be right on the money. So I just barely moved it. It's pretty coarse adjustment when it moves. So I went from here to here, just barely even touched it. See the marks here? I only moved it just the width of the marks, about all I ever moved it. So anyway, that looks pretty good there. Now you can wipe this mark off and put it straight up and down, which might make it a little bit better for the customer to remember where things are at. I didn't think it was going to be that coarse of an adjustment. So I marked everything off, wiped it all down. Come in here, our felt tip marker. And see, now I got the dot right up on the top there, more or less. So if he moves that just a little bit either way, it advances and retard the timing right there, and just relock it down, it'll stay there. So you don't have to play with these bolts up in here, which is more of a coarse adjustment. So that gives you your fine-tuning adjustment. Like I said, this will all change a little bit as things break in, they get freed up. And after things get where they want to be at, then you can set the timing for real. But for now, that's how you do that. Now to kill the ignition, we just put a ground wire up here off the post on the back here. Hook it to, as soon as you touch the ground, the motor will quit running. It shorts out the point and kills the motor instantly. He has a key switch right here also. If you turn it on and off there, it shuts it off also. Okay, so we're going to let him determine where he wants this to be. So it's way out here now. Like I said, maybe if you had a handle out here, it'd make it more fun, but oh well. Now right now you're going to have your throttle hooked up to hold it fully advanced. Usually what I do is I put a spring on here. You can go from the oil line down to here with a little spring, and that'll always keep it advanced all the way against the stop. Even if you're moving the throttle back and forth up there, just play in that mechanism. If you keep it this way, it'll keep it fully advanced, it'll be that way. These things naturally want to retard from movement, the rotation, so they always want to go backwards automatically. So as you're riding down the road, it will automatically try to retard. If you put a spring on it, it'll hold it fully advanced. That's one of the things we do on a race bike. You make sure it stays spring-loaded, fully advanced. Because a lot of times you get off the bike in the track and you find out, you go over here and bump it and it moves like this much. You go, whoa, what happened? No, the bike lost 5 miles an hour. Or 3 miles an hour, whatever. You know, you can actually feel a difference when it knocks off 3 or 4 degrees. Okay, so that's things you can do. So, like I said, just a spring from here over to your tube here. It's fine, simple, easy to take on and off, no big deal. So we'll let him determine if he wants to make an illegal looking vehicle. That would not be stock if you did it that way. Now, I personally do not like clear covers because I don't want to look at all the crap in here going back and forth. But this must be what he wanted because he has it on the mag. So now we just tighten this up. We already got the gasket on there. If you do not want to over torque these screws because you will break the cover. You do have a little bit of mechanical lock washer. I like it better than the Stars. When that runs into your foot, it could hurt. It's a good thing I got thick feet. Or I like pain, one of the two. So this has a mechanical lock washer right here. So this application looks better. There it goes. Acts like that gasket was jamming in between a screw and a thread. So I backed off, came back in, and it went in easier. Like I said, if you're forcing something that's hard to do, it's probably wrong, so just back up. Now it's under spring tension right here, so just push it down a little bit. Let it kind of center with all the screws in there, and then lightly torque it down. It's just about how much tension you run, about that much. So just 2 fingers, rotate, that's all you need. Any more than that, you'll break it. Okay. Mag's in. There you go. Simple, no trouble at all, see? Like I said, it's going to flop all over the place right now, which is not good for your timing. Like I said, I'd put a spring on it. Hold it right there, no more problems. Okay, this is plug wires right here. These go in there like this. Run these across the motor. You can run them over top where all the linkage is at, or you can run them underneath out of the way. Geez, I wonder which way I like doing it. So, run them through that direction. And you always put these in after you got the plug wires on there to figure out where you're going to be. So let's go over here, spin around. We'll go ahead and put our timing hole plug in the hole so we don't forget. That. Three-quarter inch wrench. Good torque. Okay, for spark plugs, we're going to use NGKs. Good brand. These are B6L, which are kind of hard to find. There's your part number. You have 3212 is a stock number. Okay, these plugs are made for this application. They are a 7/16 inch reach, which is odd. And they're non-resistor, and they're a 6 heat range, which means you can run them hard. If you're racing, you run an 8, but or 9, 10, you know, cold. But 6 is one step colder than normal for like a Panda or something. Now over here, we want to make sure our plug gap is narrow. You want to be running about 18 to 22 max with a mag. Unless this magneto's got some kind of magic power where it's really putting out juice, you better run it narrow. So I'm not sure what kind of mag this is, so we're going to put this thing down there about 20. So that goes in there, still fits in there, so get it on the bench until it quits moving in there. Getting closer. There we go. Oop, almost held. It's trying to stay, so that's 20, 21 maybe. Alright, so that one's ready to go. So I have this special plug indexing tool right here. See, it's called a workbench. Otherwise known as you drop it on the floor a couple times. Oop, almost held in. Just like the other one's trying to hold but not quite. Oop, I think we're off camera there. Using a flat gauge is hard to measure. Uh-oh. Appears I went too far. Jeez. What are we going to do? Have to buy new plugs now. Damn. We're just going to go in there. Move it up a little bit. Start over. Trying to stay in there. Okay. So now we just screw these in. Find the right spot helps. You can either use anti-seize or not. Anti-seize keeps it from seizing up and rusting, but it also is not a conductor, so it blocks voltage. So if you want to use it, use it. If you don't, don't. Cast iron heads, you don't need it. Aluminum heads, especially newer aluminum heads, the alloys don't like. They like to stick. The old Panheads and stuff like that, they have steel inserts in the head, so it's not really an issue. It's only when you got that raw aluminum against steel is a problem. If it's steel against steel, you don't really need anti-seize. That is up to you. Whatever you do, just make sure it never gets on the tip of that plug. It'll never work again if it does. Okay, I like to torque them down until they quit moving. Pull back and complete it. I'm sure there's all kinds of negative comments about me doing this. So. There you go. Okay, now we got our plug wire on here. Pull it off the other side. Make sure it's on there. The other one across over there. Get this one up here. So I like them going like that. Remember, it's the higher you go, the hotter it gets. The lower you are, the cooler it goes. Don't forget. Okay, let's see what we got to work with here. This one goes here. And this looks like a little bit longer, so it goes up here. And make sure it goes all the way down in there. Sometimes you pull the boot out, make sure the wire's on, and slide the boot down, so you know it's got full engagement on there. This one feels soft. So I was trying to get the boot doesn't want to move up, so try to move it up anyway. There we go. Okay, so the wires are now on there. See, there's no twisting to them. They curve underneath here pretty good. The linkage is up here, so we should be clearing everything. But once it gets carbureting, you gotta make sure nothing rubs on the plug wire. If you do, you gotta move it somewhere else. We're in a relatively cool location because we're down low. And they kind of wrap around a little bit. Now you can put insulating material on here if you want. Some kind of heat shield and keep from rubbing on there if you want to. Harley never ran anything like that. Anyway, they rub against the fins, that's how they go. Now if you want to go over the top of the motor and come up this way, then it's a lot hotter up here. But you know, it's just another way of going. It's, you know, there's lots of ways of doing things. Whatever works for you is the best. I don't like it when it's real hot. You know, we're up against the head here, that's not good. It'd be better if this was down lower. And if you put a couple zip ties in here like this, they'll all stay down a little bit lower. So you put one zip tie over there, probably 3. One there, one in the middle, one here. That'll straighten out when it comes through and keep the heat lower. Like I said, if you put a little insulating material between it, it helps also to keep the heat off. But right now I don't like it this way because it's up against the head. So we'll have to let him play with his stuff a little bit. He's going to have to figure out what he wants to do. Alright, so we got the plugs in, we got that all in there. We don't have the cover on yet there. I don't have the cover, so at least I don't think I do. So we don't have that. I know I don't have the kicker cover, so I can't kick it. And so the last thing to do is put the covers up over here, it looks like. And I don't have a carburetor, so the last thing we're going to do is put these clips up in here. Just like before, we're going to use our little screwdriver. What do I do with the clips? Clippy clippies, clippy clippies. There they are right here. That one doesn't want to go in. That one's going to be a problem, I can tell already. Pretty tight. These have like twice the spring tension stock stuff does. Because you got that late spring in there, a lot stronger. That did go in there pretty good. Alright, just rotate. Now when these covers hit on the fins on the backside, they will stop and won't come down. You can walk it down with a screwdriver by going like this under the fin. See? That relieves the tension. You can walk it down and then put the clip straight in. That's what you have to do when it doesn't want to work that way. These ones went in pretty good. Alright, so our motor is pretty much done at this point. So the only thing we have left to do right now is we're going to have to do the generator. Needs to be rebuilt and put on. And that's all I'm going to do on this. It'll be done after that. So for now, the magneto's all in, everything else is done, and we're ready to go. So that's it for this.